All right, here we go. We are at video 3 right now. And well, Mr. Lockhart, if you could just take us through what's happened in videos 1 and 2 using this wonderful graphic.
You bet, Mr. Lee. So we started off with some solid copper powder, and then we added some nitric acid, and we made a copper nitrate solution, and we lost that nitrogen dioxide gas. Then we bring it on down here, and we added some sodium hydroxide, creating copper hydroxide, and that was that kind of cloudy, darker blue liquid that you saw. And then we put it on the heat plate, we added energy, and we then created copper oxide. So then we took that copper oxide and we poured off the liquid, collecting the copper oxide into a filter. And now we're going to do something else to it.
All right, so that's where we're at. We've got this copper oxide, we got the solution. So let's go over to the fume hood again.
So now back.
There we go, we're back. There is your copper oxide. Basically, copper oxide is copper rust, right?
Yep.
All right, and what we're gonna do next is using a small spatula. That is a scientific spatula right there, used for scraping. What you need to do is to gently scrape the solid from that paper into a 100 milliliter beaker. So you're gonna open up that paper and you're gonna scrape as much as you can. Now you can use the same beaker that you were using to drain before. Just make sure you empty that beaker first. Ew.
Does not
It
look
looks
like
like
anything
gunk.
pleasant. It looks worse than gunk.
Zoom in here if I can. You guys can see that's that copper zinc solution. Basically the same thing that you would get if you left a penny out for way too long in a wet area. Penny would oxidize looking at something like that. And that's why you wear gloves. Excellent. All right. So now we've got this copper oxide solution. What I want you to do now is to measure out 15 milliliters of sulfuric acid, H2SO4. Okay, so measure out 15 milliliters. Get out of your way. Notice he's using a graduated cylinder, actually measured already out to 15 milliliters using the plastic part. Very good. Excellent. Good job, Mr. Walker.
Thank you.
Okay, so as you add this sulfuric acid into the beaker, am I in your way?
A little bit.
Be safe. As we add this, you want to stir it with a glass stirring rod. Remember, we want to use a glass stirring rod. If we use the metal stirring rod, likely what we would do is oxidize the metal and it would ruin the experiment. Glass stirring rod is not correct. So now we've got this brown sludge. And we're looking to see if anything happens. And what I'm starting to see here, Mr. Lockhart, is a small change. It started off as a dark brown, and now, oh look at that. Suddenly, very quickly, it is changing colors again. And am I seeing another precipitate coming out of that?
I'm not sure. I don't think
Not
we're seeing
quite.
the precipitate.
Not yet. But it's still changing colors.
I think what we're seeing is the acid.
Oh, that was the sludge from before, right?
Yeah. So now we've seen the acid, just like the nitric acid, operated on the copper powder. Now we're seeing the sulfuric acid operating on the copper oxide.
And now it turned, without adding really anything else, into really kind of a bluish solution. Tilt it the other way. There we go. Oh, that's what? Kind of a bluish solution. All right. So the next step is we're going to add some zinc filings, which we don't need to be here. We're going to back off and go across the room and hand it off back to Miss Sobatova again.
Can
All
also
right.
have the stirring rod too.
Oh, yes.
Yeah, this is amazing. So what you guys made is a copper sulfate. So you added sulfuric acid to your dark solid copper oxide, right? And that turned the dark solid into the blue solution, or made the blue solution copper sulfate. So that's where sulfuric acid, sulfate ions come now. Copper sulfate.
Okay.
Okay.
Excellent.
All right. So we are into next step.
Excellent. The next step, which reads, measure approximately 0.1 grams of zinc filings, anywhere between 0.08 and 0.12 is fine, and add the zinc to the beaker. Stir the solution until it is colorless and record your observations. So here we have zinc filings. Zinc, very similar to what we used in the first lab, right?
Zinc powder.
Zinc
And
powder.
this
So
is
instead of little
dust.
granules,
Yeah.
this is powder.
And you want to make sure when you first come to the scale, when you put your weighing dish, if it doesn't reach 0, you hit the 0 button. It says 0 in there. That just zeroes it for you so that the weight of the dish is not considered in our 0.1 gram of zinc, right?
Excellent.
Okay,
So we need 0.1. So 0.1.
just like with copper, we needed a little bit of copper, so it would also be.
Ooh, went
That's
a little bit
too
over.
much.
So we're going to scoop some of that out.
What is it right now?
A little too much. It'd be 0.12. That works.
Yep. Anyway, between 0.08 and 0.12. So 0.12 grams.
0.2 works great.
Perfect.
All right. And what we're going to do is going to add this powder to this solution. And it'd be really great if we had a white piece of paper to put below that so that we could see it a little better. I think Mr. Lockhardt's got that. Here we go. Oh, look at that. It's already bubbling and a fizzing. Oh my goodness, look at that. You're gonna stir that up.
And record all your observations. The bubbles need to be written down. And then what do you see happening with the solid part? What are some solid chunks?
Now, before we
Here.
came over here, there was no solid. So are we looking at the zinc solids right now?
That was zinc, yep.
And now that zinc is reacting to the solution that we came to over here, which was
Copper sulfate.
copper sulfate.
So you had the blue copper sulfate solution, and zinc is reacting with it. And notice our blue is disappearing. It's more like clear solution now.
So the blue likely was the copper, and the copper is now reacting with the zinc, just like it did in the lab before.
Very good.
And what we're seeing inside of that,
If you can see it, yeah, the
yeah.
solid zinc is not gray. It was gray
it was
originally.
gray before. Let's I'm gonna open this up and see what the zinc looks like. So I'm gonna go back and show you. This is what the zinc looks like in the container. It's kind of a powdery gray. Okay, that's a big clump of it. You see, it's a gray powder, and that's what we put into the solution. And you can, that's definitely not gray anymore. That is copper colored, which makes me think that Miss Sobatova, that copper solution, what was in that copper solution, has now precipitated onto the zinc chunks.
Yeah, so what happened actually, zinc is in the solution now. Zinc is zinc sulfate. It kicked out copper from copper sulfate, replaced copper, and it's in the solution. Thus, the color of the solution changed to more of a clear because zinc sulfate solution is clear.
Awesome.
So what we are left with is copper. It's not zinc coated with copper, however, it's just pure copper.
Okay, and I'm gonna, for safety's sake, I'm gonna put the lid back onto the zinc, and it says in the next part of the instructions, pour off most of the liquid into the correct waste containers. And we have waste containers, which would be kind of a larger beaker. And you're gonna pour this out, but you're not gonna dump the copper out, right?
Yes. So pretty much your experiment, the goal was for you to see copper cycle, right? So you have it right here. What we're just gonna do is wash it off to make sure we just have the solid. So we get rid of zinc sulfate solution. Make sure you don't pour all the copper, so only copper left, and get yourself about 10 milliliters of water. Is that right? Is that 10 milliliters? So you can use your wash
Add about
bottle.
10 milliliters of water, swirl the solution again, and pour off most of the liquid into the waste container.
That's about 10 milliliters. We're just washing off our copper pretty much.
Excellent. And then you pour that out. All right, so we're left with, this is the observations that you need to record.
And then
Let's
this
put this
copper
down
actually.
over to the white paper so we can see this a little better. Oop, sorry, I'm messing with you guys' minds here. Focus, there we go.
And this copper should be approximately the same amount as we begin with. So about 0.10 grams.
Excellent. And now, the really important part. This is, look at all this mess. Look at all of this mess. Miss Sobatova, Mr. Lockhart, clean up.